Lesson 1-1, the rational numbers. So in this lesson, we're going to look at three things, or do three things. First, we're going to define what a set of rational numbers are. We are going to identify subsets of rational numbers, and then we're going to write rational numbers in equivalent forms. So first off, what's a rational number? A rational number is just a number that can be written in fractional form, which means a over b, or a divided by b, where the denominator can't be zero. If the denominator of a fraction is ever zero, it would be considered undefined. You can't divide anything by zero. Next is a subset. A subset is just a smaller set of numbers that are part of a larger set. One way to think about this without numbers is if you think of a carton of eggs, you have a carton, which is a large set, and inside the carton, you have some smaller sets. You have some smaller eggs inside there. So we would say that the egg is a subset of the carton. And you're going to see what the subsets are when we're dealing with number sets. We have terminating decimals, so decimals that come to an end. And repeating decimals, those are decimals that have a digit or more than one digit that repeats in a pattern and it never ends. So here is a diagram you've probably seen before. Here we have the smallest group here is natural numbers. Natural numbers are 1, 2, 3 are your counting numbers. Inside, the natural numbers are inside the whole number oval. So all natural numbers are whole numbers. The only difference is 0 is a whole number, but it's not a natural number. And then natural and whole numbers are inside the integer oval. So that means natural and whole numbers are also integers. So natural are subsets of whole. Natural and whole are subsets of integers. That means natural, whole, and integers are all subsets of rational numbers. And you can see the rational numbers, that's the first time where you see fractions and decimals involved. And natural, whole, integers, and rational numbers are all subsets of real numbers. So rational numbers include, as we just said, integers, whole numbers, natural, or if you want to use counting numbers as well. We are going to write rational numbers in multiple ways. We can write them as mixed numbers. So an example of a mixed number would be 1 1/2. Improper fraction would mean I take the denominator times the whole number. So 2 times 1 is 1, or is 2, and then add the numerator, which 2 plus 1 is 3. 3 halves, because the denominator would stay the same. That would be an improper fraction. The denominator, or the numerator, is larger than the denominator. Terminating decimal that ends. So an example would be 0.5. And a repeating decimal would be like 1.3 repeating. The 3 repeats. So that's 1.333 to infinity. And we have whole numbers or integers. So an example would be 4. 4 can be written as 4 over 1. So that's why it can be considered a rational number. We just write it as 4 because 4 divided by 1 is 4. So let's take a look at some examples. Here we're going to write the sets of, or the subsets that these numbers belong to. So what subsets of real numbers would that be? So 7 can be written as a fraction, so that's a rational. And if we go back here, you can see that I have these letters here. These letters represent the sets. So I'm going to use those to help us do this a little bit quicker. So integer or rational numbers, that would be the letter Q. And these are like bubble letters. So we have Q. It's also a integer. Integers were Z's. We have whole numbers. Whole numbers was a W. And then we have natural numbers, that's an N. Now I'm just going to write the letters, not the bubble letters, but just the regular letters for those. -10, that is rational because I can write it as a fraction. So Q for rational. We have integer. So integers would be z. It's not a whole number because whole numbers are 0 and all positive numbers. This is negative, so it can't be a whole number. Negative 4 and 4/5 is a mixed number, so it's a whole number and a fraction. So that is rational. It's nothing else because it's not a counting number, it's not an integer, and it's not a whole number. And this last one, negative 2/9 is also a fraction, so this would be rational as well. More examples we just did, negative 2/9. 0, I can write as a fraction because it's be 0 over 1, which is still be 0, so that's rational. It is an integer, so that would be z for integer. It's a whole number because it has a 0. 0 is included with the whole numbers, so this is a whole. It is natural. Actually, it's not natural because natural are your counting numbers, and we don't count by starting with 0. We always start with 1. And our last one is also a fraction, so this is just rational. Moving on to sample problems B. Here we're going to write everything in fractional form of A over B. So even though we have a mixed number here, a fraction is involved with it, we need to put it as an improper fraction. So to do that, I take the denominator of 11, multiply it by the whole number on the side. So 11 times 3 is 33, and then I add the top. 33 plus 4 is 37. The denominator stays as 11. Because my number was negative, I make that negative. Next, negative 13. So that would be a negative 13 divided by 1. So these are equivalent. They mean the same thing. So negative 13 divided by 1 is negative 13. Next, 15 and 2/3. If I multiply 3 times 15, I get 45. And then I add the 2 to 45. 45 plus 2 is 47. Divided by the denominator stays the same as 3. So 47/3. Next, we're going to write these as decimals. Now to write fractions as decimals, just treat it as a division problem. So it's going to be the numerator, 5. And I'm going to put 0.000. I'm just going to put a bunch of zeros at the end because I got to find out how many times does 6 go into 5. So I put my decimal point there. 6 cannot go into 5, but 6 can go into 50. It goes in 8 times. 6 times 8 is 48. Subtract and I get 2. Bring down the 0. 6 goes into 20 3 times. 6 times 3 is 18. Subtract below, you get a 2. Bring down the 0. 20. So we just had that 20. We said it went in there 3 times. And it's just repeating that. So the 3 repeats. So the answer would be negative because I had a negative in here. 0.83 with the bar over the 3 because the 3 repeats. Next, if I have a mixed number here, the whole number is the first part of your decimal. The fraction, we have to find the fractional parts. So we're going to do the division. So this would be 4.000 divided by 25. So 25 cannot go into 4, but 25 can go into 40. Actually, that should be 4. Let me get that. This should be 6. So 6.00 divided by 25. Now 25 goes into 60 2 times. 2 times 25 is 50. Subtract and you get 10. Bring down the 0, you get 100. 25 goes into 100 4 times. 4 times 25 is 100. So I have a decimal of, because of this 4 here, that 4 is in this place. And then I put the decimal point to 4. Next is 9/10. So anything, if you have like 9/10 or 9/100, those are easy to convert to decimals. But if you couldn't do that in your head, just do 9.00 divided by 10. Put a decimal point up. 10 goes into 90, 9 times 10 is 90. So this would be 0.9. Now, if you had a calculator, you can always put that on your calculator. So if I did negative 5.6, you can see negative 5.6 here is negative 0.83 with the 3 repeating. And if I hit the math button and did number 1, I could put that as a fraction again. Or if I hit math another time and do number 2, which says decimal, I can convert that to a decimal there. Next, we're going to be looking at patterns with repeating decimals, or even if they're not repeating. But patterns can be seen when writing rational numbers in fractional form as a repeating decimal. We're going to look at these decimals here, or these fractions, and convert them to decimals, and we're going to look for a pattern. So the quickest way is we're just going to put this on our calculator, and we're going to look at the patterns here. So if I do 1 divided by 11, so when you put it on the calculator, the fractional bar line is just the division. So if I hit enter, I get 0.09, and it's the repeating 0.09. So let me write this down. So this would be 0.09, the bar over the 0.9. Grab our calculator again. Now let's do 2 divided by 11. And we get 0.181818. So the bar is over the 1/8. Now if I do 3 divided by 11, 0.272727. If I did 4 divided by 11, you get 0.363636. So you should start seeing a pattern. And the pattern is if I take 1 times, it's actually, they're actually counted by 9s. So 1 times 9 is 9. So you have 0.909. 2 times 9 is 18. So 181818. So there's your 18. 3 times 9 is 27, and you get 0.272727. 4 would be 36. So 4 times 9 is 36. So 3.363636. That means 5 times 9 is 45. So that'd be 0.4545. 6 11s. 6 times 9 is 54. So that'd be 0.5454. So what do you think 9 11ths would be? Well, 9 11ths would be 9 times 9 is 81. So this would be 0.9 or 0.81 with the repeating sign over the 8 and 1. So the pattern is you're just multiplying the numerator times 9, and that's going to give us the repeating decimal. So that is our lesson on the rational numbers.